MC Toon, and it's Tuesday night. I just finished a debate talk with a Pumpy the Bear, and I've got with me now, I've got Keith. How you doing, Keith?
Doing all right.
I don't want to get the. You know what? I messed up his name before. So, Keith Ivan Mitchell. Keith Ivan Mitchell. I almost said the wrong thing again. So, all right. How are you?
Doing fine.
And I asked him if he's going to be on camera. He said no. So
maybe by next year.
Maybe by, yeah. I like your idea though, for what you're going to do.
What part? What are you talking about?
Your idea for when you do go on camera.
Oh, okay, got you. Yeah.
Tell them.
Tell them. Oh. I'm going just like my man, Flat Earth Hero with the shades, people. Rocking the shades on camera. What's up, everybody? Indoors. How y'all doing?
Oh my gosh. So I have, yep. Well, it'll look like this, right? There we go.
There you go. See? That looks
just
good.
Like that. All right.
With the 8 bits.
The 8-bit sunglasses. I have, where'd they go? I have some different ones. They're not here. All right. So, you called this meeting, Keith. You called this meeting. So, why don't you give a little background to this?
No, this was basically when you from way back in the, this is like almost a year ago, I think, right? When you chopped up Stinky Fish's moon phase video. And then I kind of got to you about that, like, man, why did you chop up that video? Why did you mess that all up? He did a better explanation than what you did.
I don't remember chopping up his video.
Well, I mean, not chopping it up, but I mean, like, he was supposed to come on, he didn't show, and then from there, you just kind of took over and just kind of talked about the video and all that.
Oh,
stuff.
yeah, okay, yeah.
That's what I mean.
Yes. So what was it about that video you didn't like?
Oh, well, I mean, I was basically trying to talk about the moon, and, like, all things the moon really was what I was thinking about. But I was just saying, in particular with that, I do think you killed his phases. Like, the way he was showing the phases, he was just trying to show as the moon is going around, you know, just what we kind of know already from school, but just the why for flat, what's happening and what the phase is going to be and all of those things. I would say one thing. I think one mistake you make, though, that you guys tend to make, you keep that scale of whatever size it's supposed to be. If we're a globe, you keep that scale and bring it down if it's flat, and that's the problem. Can't do that.
What do you mean?
Because the moon and because like usually if I see if someone is doing a joke and they bring the moon down on the flat and they say that you should see different angles, it's not the size of a small city. It's like the size of like half of a continent or something like that. You've never seen these things when they try to say that with the moon?
So it's not to scale.
Right.
Yeah, well, so typically diagrams of things that are very, very large, you can't do to scale because then everything's tiny if it's to scale, right? If the distances are large, then you have like the moon is just a dot and the earth is just a dot or whatever. So it doesn't, yeah. If you're trying to get something to scale, then do it to scale if that's necessary. But if you're trying to do just something for illustration, then just do something for illustration.
Well, sure, but I would say that the illustration the illustration forces the point that people will see different sides of the moon based off of the size that they're using, as opposed to a speck of a city, as if you looked on that map, what it would be. Okay. Its actual size, because it's a speck of, it's like a city. It's like I say, 32 miles, 40 miles plus around there. If it's at 4,000, it might be higher. So I don't necessarily go against that, because you know how I feel about the refraction and everything. I think it's way more than what you guys say it is. So.
And that's based on
the refraction?
Nothing.
Refraction part?
Yeah. Why do you think it's more? Yeah. Do you have evidence that it's more, or is it just you want it to be more?
I don't know about want, but something tells me it's not what you guys are saying. I guess I'll say it that way. Yeah, I don't have the proof to show you. Hey, look, right here. Look, ABC. This is how we know. No, I don't have that. It's a hunch right now that I believe that the refraction as you think it is. Once I fully go over it, I'll be able to fully explain it, of course, at that time. But yeah.
So I put up the what did you want me to put up for you?
Well, I was saying my chess piece on my picture.
You're like,
you got the other guy.
use the Black Knight. So I'm like, oh, from Monty Python. So he's up there. I got the Black Knight from Monty Python. He's invincible.
Go for it.
With his arms and legs cut off.
Hey, he gonna become spirit and he'll become more invincible. He'll be all right.
Ooh, Man Devil gave me some strategy. He says first go for the arms, then for both legs. So that's what I'm going for. Okay, so there's something about the geometry that you wanted to cover.
The geometry. What did I say? The geometry?
I don't know. You would in a
comment.
comment.
I just said moon or something like that. That's why.
Okay.
Geometry. What do you mean geometry?
I don't know.
Try to find that, I guess. I think it was the size. I think it was the scale thing. I think that's what it was.
Just the scale in the not to scale drawing.
Just the scale. No, I mean everything, but I mean like the way you were doing the moon phases and said like you should see a different angle. I don't see how you guys say that. I don't know where that comes from on that level. And then when it comes to go ahead.
A different angle. So the thing is, I mean, the moon phases. Oh, for flat Earth. Yeah. So and you can't draw that to scale because it's just a dot. But if the Earth were flat, then the phases of the moon would be different. Not based on what time of month it was, but where you were and what time of night it was. Right. So if the moon is above South America, right?
Mm-hmm.
Or the equator. Let's say it's above the equator. And somebody in and the sun is this is flat Earth, and the sun is somewhere farther around, so maybe it's above I don't know, Asia, right? So if somebody's in the northern part of South America, they should see a large portion of the moon illuminated. And if somebody on the opposite side of the moon there, right, in the southern part of South America, they should see the moon illuminated very little. But they don't. Everybody always sees the same amount of illumination of the moon.
Right, but I'm still, if everything is scaled down, what would be the difference? That's the part I'm missing with what you're saying. There should be, it would not, if it's actually scaled down appropriately, there would be no difference.
Scaled down appropriately. Yeah.
Right.
What do you mean?
Meaning like the different angles that you're talking about that we're seeing. Okay, so if it's 230, basically 230,000 miles away. Okay, we're sending it that far. We can only see the side because of X, Y, Z. Okay, scale everything down appropriately in the right size. There would be no difference.
Yeah. So make a scale model of the solar system or the Earth Moon system. Right? Make a scale model of that. Make a scale. Make a scale model of the Earth Moon system, and then see if that scale model is illuminated appropriately.
Okay, no. When I say scale, what I mean is come on, man. Ratios, triangles, sine, opposite side over the got me saying
measure
over hypotenuse. I mean,
do the trigonometry you're saying.
Well, come on. So okay, proportions, dude.
I'm trying to understand.
So if the ratio proportions are still the same, okay. Well, the best I can say from this is with the ratio proportions of what we can see with the moon, as you guys believe it is, with all of those ratio proportions. If you made it flat and kept the ratio proportion for however lower it is, how much it would shrink now because of that, those ratio proportions are still the same for us. So we would not see different size. We would still see exactly what we see regardless of which it is. Because if it's flat, it's still scaled down to where we can still only see it that way. That's the best I can give you.
I don't think I understand what you're saying.
Okay, I mean, I grant, but I think that's the best I can give it.
Um, you're saying
It's like, let's try this.
okay.
Well, hold on. Let's try this. Okay, so we have the Greeks. So the Greeks would see a tall column, and then the Greek would have his own stick. So he would look at the column and then look at the stick and say, okay, I can know the ratio of the column based off the fact that the sun's rays and the shadow, they're going to be proportionate. Those ratios are going to be equal in proportion. So you take the proportion of the stick, and then you check the shadow of the column, and then you know the height of the column.
Okay.
I gotta get into yeah. Well, there you go. That's the answer. So therefore, if a moon was scaled down, it would still look the same. It wouldn't be different because the ratio proportion is the same. That's the best I can give you, man.
Right. Yeah. I don't know. It's not doing anything for me here.
Okay.
Now, all right. I don't know if I can go any farther on this because I'm just not getting what you're trying to say.
Right. Well, I mean, we don't have to stick on that one. I mean, we can do other things on the moon, but I mean, yeah, because right there, that's about as far as I know how to. Well, I mean, like for instance, 1/2 is equal to 5/10. That type of racial proportion.
Okay.
You still don't get it?
Well, I get that. That's the same raw number.
Right. And that's the thing I'm saying about racial proportions. So when it comes to your eye angles and what you're seeing, it's going to be the same raw number, so to speak.
Yep.
Just because it's flat, it will not change, is my point. It will be those same proportions. Those racial proportions are going to stick. Still a little rough? All right. I'll try to, when I get the channel, I'll try to smooth all that out.
But is the point of what you're saying is that if it's flat and local, then it would work because the scale is going to work, then it's going to be a correct scale?
Right. The scaling would come down. It would be appropriate for whatever our measurement is in this place, and it would still be the same.
Okay. But the problem is that there's all these other things that wouldn't work.
Throw them at me. Go for it.
The angles, like I said before, if right, so you could say, well, let's just move the moon closer. It's not the already measured distance to the moon. Instead, we'll just make it close for no good reason. We'll just put it close. And the thing is, though, if it's close, right? If it's above, if the Earth is flat and it's close, and it's maybe 3,000 or 4,000 or 5,000 or 10,000 miles, doesn't matter. Much less than 238,000. Then when you are on the point of the Earth that's directly below the moon, you are the closest to the moon. Right? You are the person that has the closest distance to the moon, so it should appear to you to be the biggest. Then you take the person on Earth that's very far away from you, as far away as you can get, and then they can look at the moon and they will see a much farther distance to get to the moon, so it should appear significantly smaller to them at the same time, right? That's perspective. Perspective is uniform reduction in angular size with increasing distance. You get farther, it looks smaller, right?
So okay, so let me ask you this. Use your same scenario. What's different? What would you say is different for the moon being 230,000 miles away? There's somebody directly under it, and then there's going to be somebody else somewhere else. But you're not going to say what you said before for this situation, are you?
If the moon is very distant, yeah, there's still going to be somebody very far. The moon, yeah, there's a sublunar point.
Right.
And there is somebody that's very far away from it on the Earth. But because the moon is far away, I'll draw a picture, not to scale.
All right.
Right? Because to scale, this would be a useless picture.
It would be small. That's the point. Yeah, exactly.
So, in fact, I won't even include the moon in the picture. All right. So here's the Earth. part of it, the part of the Earth that's facing the moon. So the moon's up here, we'll say, right? Somewhere off the page, right? And so this person here looks straight up and sees the moon straight up. And that person is the closest to the moon. They're 238,000 miles away.
Right.
The person over here is farther away because they got to go this distance, right? So the radius of the Earth distance away plus the little bit of trig here to get the hypotenuse. So the radius of the Earth plus a little more. So they're a few thousand miles away more. So this guy's 280,000 miles away, and this guy's 280 and a few more thousand miles away. But the difference in angular size of the moon from these two people is not zero, but it is very small. Not something that you can see with your eye. You would need a very good instrument to measure that distance. The difference in angular size.
Right.
So
and all I'm saying is that, so for me, what I'm saying is that for flat, it's still those same proportions.
It's very different
still
proportions. The proportions are very different though, because the moon on the flat Earth is 4,000 miles away, let's say, right? The person directly below.
Possibly, maybe not.
Let's. I'm not going to stick you to that number. I'm just going to use a number that we can actually just put something to. And then the person on the Earth is 12,000 miles away from the sublunar point. The hypotenuse of that is more than 12,000 miles away.
Right.
Right. So you've got somebody 4,000 miles away from the moon and somebody more than 12,000 miles away. That's triple the distance. Versus this, where you've got somebody 280,000 miles away and somebody 280,000 plus a couple thousand more miles away. That's not 12x difference. That's 1.0000 something difference. It's very small difference. So the scale, you can't say the scale is the same.
Well, I'll say this. I would have to go in and I mean, I know y'all. I mean, I'm with it too. I'm with the math too. I have to go in and really go in. But see, this is why I go back to the whole. This is why I realize with trigonometry. That's why I go back to what I say about refraction. I like, wait a minute. There's something else. There's something else that's up here. So I definitely have to go into that, and then from going into there, I'll be able to clear that up. But for me, I would still say that the proportions are going to be equal. I mean, I understand what you're saying, but the proportions are going to be equal. I don't know how it works exactly. I got to go through it. But for me, I think the proportions are equal. And I just have to go over the numbers to figure it out.
Maybe I'd love to see your numbers. And I know you've been doing some brush up on your trig, right?
Some.
Yeah.
I'm going mathematician supreme, son. Awesome. I ain't going no some.
I didn't want to make assumptions. So here's the deal. If you saw me last stream, I have a slide rule that I don't use for doing math, right? It's really small numbers on there, and I can with these glasses read it somewhat. But what I do is I put these on, and then I can read. This is easy to read now because these are very strong glasses. Can you see? Look at that! Aren't these awesome, sexy glasses? So I know sort of how to do it, but I'd much rather just use a triangle calculator on the internet.
But that's not. Come on, learn how to do it yourself. You get in there and just stay versed in it. You know.
Right here, I do this. I use my calculator to do it.
Let me tell you something, man. I went into that.
What do you think?
I went into that calculator.
You like this calculator?
I went into that calculator. I went into the calculator and I started to realize
that's a sexy.
There's different things to it.
There's different things to it. Yes. Yes, there are.
It's kind of funny that sine 1 degree and tangent 1 degree are the same, and they shouldn't be. But I know what they're doing. I know why.
Should be, yeah. So let me add. Let's see. Do you know Patrick Butler? He says the moon has pre-programmed hologram settings.
Is he flat Earth?
Some people think he's a Poe.
Sometimes, there's different variations for people when it comes to that type. They might not necessarily be flat Earth if they go with that. I was just curious.
Yeah, some people say that Patrick Butler's a Poe. He's on Facebook a good amount if you've ever seen him around there. Yeah, he says the moon has pre-programmed hologram settings.
Yeah, he might be joking in, I guess.
That's all right. So Kyle Bro Estler says he's saying everything works on flat Earth, just scale it down. Yeah.
You still have an issue with it, huh? You're not getting it, huh?
I get that's your claim. I did get that part of it.
Okay.
But what I don't get is that you think that it actually is correct. You, you need to
remember now, too. Well, hold on. Remember now, you chose 4,000. Like you said, you just want a number out there. And that's why I keep saying I don't know about this refraction. Yeah. It may be more than what's... Okay, hold on. Well, hold on. What if it's 40,000?
What? Well, then it will be closer. If it's 280,000, whatever, it will be very close. In order to make the flat Earth work for just the angular size of the moon at different locations on the Earth, in order to make that work on flat Earth, you'd need to move the moon as far away as we say the moon is.
Well, okay. So
pretty much. So, I mean, but do the math and show something else. I'd love to see that. JDT Turbo has a very good point. He says, he or she, I don't even know, says the measurements of Earth's curve scaled down would still be curved.
All right, hold on. The measurement of Earth, what do you mean? What is he talking? You mean like if you had a globe and then you make the globe smaller, then yeah, what about it? Or bigger, right?
Yeah, sure. Scaling down the globe, everything is still curved. All right, hold on a second.
Or scaling it up, right?
Somebody thinks I look like Bubbles, apparently.
Who's Bubbles?
Well, hold on a second. Oh my gosh, these are just, I can't hardly read anything. Use space words, Ricky. There you go. Facty. Or extra J. Extra J, there you go.
Now see, I got somebody else. I see I've got F Up World in my corner as an FB space believer as well, huh? Any others?
Well, you got Mallory.
Okay. She believes in space too.
She didn't. She's a flat earther. I guess I didn't know what.
Right.
Yeah.
But I mean space. I like the fact that he's space. I got one other at least.
So S Thurston says tangent of 1 is 0.0174551 and so sine of 1 is 0.0174524. It's close, but they are not the same.
Well, hold on. Okay, well let me give you mine then.
You need to go. Yeah, they diverge at 1, 2, 3.
Okay, so sine what happened?
The fifth significant digit, they are not the same.
Maybe. So I'm gonna just go to 4. So I have 0174, but I got a 5. I'm gonna just make it 0175, and then I'm gonna hit tangent 1. I got 0174 with the 5 to make it 0175. Tangent is sine over cosine, so it's not going to be the same. But the computer does it to average out the numbers and approximate them. That's why it does it. That's why I think I understand why it does it.
And just go into Python and set, super aggressive significant digits. I like that. Or Java. Okay. If you're a real programmer, do it in Java.
Java. Okay. Yeah. Okay. And that's the other thing too. Yeah.
Big decimal.
I'm getting on your computer programming and your computer programming as well. I'm starting to learn those languages between Java and all those different names and all that. But yeah.
Yeah. What language have you programmed in?
None yet. I'm learning it. I'm going to get the book so I can start learning how to do all that stuff.
Start with Python. Get the book that's got the rat on the cover. It's a very good one. Okay. You can get the PDF for free online. I own the book. It's on my bookshelf here somewhere at work. King Crew says, I made it. I'm here now. You can start the stream over. Oh, thank you, King Crew. All right, everybody, we're going to start over. Welcome. It's Tuesday night, and Keith is here.
What's up, ball babies?
Oh my goodness. Blackburn Big Dragon says he's learning Commodore 64 assembly. Wow.
Commodore, is that the game? Is that like the game format?
Commodore 64 would be a computer from the 80s.
Right, the game one, right?
The what?
Just like Nintendo. It wasn't. Commodore was a game like Nintendo, I believe, back in the day.
No, it was a computer it was a keyboard. You could play games on it.
Right, okay.
Yeah.
Right.
But now here's what you did. If you're gonna play a game on a Commodore 64 and you didn't have whatever was the hardware to make it go fast, you go over to your friend's house and you're like, hey, let's play this game. And you start it up, and then you go outside and play outside for half an hour to an hour. Then you come in and you're like, oh, it's not done loading it. Let's go back out. So you go back outside and play a game. Right, then you come back in and it finally is loaded. And you're like, awesome, let's play the game. You're like, oh, this game sucks. Let's do a different one. So you load that one. For an hour, you're outside playing. So it was really good. You actually got to play outside. There it is. Gary, do you know Gary Wybenga?
A little bit. That's my man over there. Y'all be shutting him out. He's trying to give y'all the truth. He's hitting y'all up. Y'all just want to push him out, I guess, huh?
The Truth and Gary have never met, but Gary seems to want to be open to debating Professor Phil Bell on here. So, what would you think of that?
Hey. Woo, wait. I mean, I figured I had to get into a few more physics books before I would go ahead and go up against Professor Bell. But if he say he got it,
I mean,
go for it.
Gary Wybenga is very confident of himself. So confident that you might suggest that he suffers from Dunning-Kruger, but he would disagree. I'm certain he would disagree.
Oh, I don't know about all that. I've seen some of the things he's posted on things you've had, and he's given some good basic observations of just like, wait a minute, how do we just see this if what you're saying is true? I mean, that's most of us. That's what most labs are going to do, because obviously, a lot of us have not gotten into, here we go, no jokes, please. But none of us have not always gotten into all of the physics yet. We're getting there. But, as we're getting there, we're going to get more developed with that. We'll know how to speak that language so that we can more appropriately say what we're saying. So for what you know. Yeah. I have one here. What about the radio waves? You guys go back. You guys love the fact of bouncing the radio waves off. All you're really getting is the timing is coming back. You're not really, how to say this. You guys are basing the distance off of the timing of the radio waves coming back.
That's one way to do it. Yeah.
Right. As opposed to, well, I mean, again, scale, where it could be closer, and the numbers you thought of further, we're just going to bring those down. And so when it goes to the moon, it's that closer distance, but you guys make it that longer. Another one you don't get.
How could you possibly think that radio waves are somehow wrong?
No. Well, no. I'm saying the interpretation of the timing that it comes back upon.
So do you think light travels at a different speed?
Well, I guess wavelengths, I guess is what I'm saying. Overall, it would be probably electromagnetic, and that whole overall spectrum is probably at a different scale. Well, let me put it this way: if you shoot it, we can even do it to the sun, I think, as well, right?
Yep, we've bounced radar off the sun.
Off the sun. So, and that takes about 8 minutes.
And then,
right,
980 seconds is about it. Yeah.
So, well, let's wait. Hold on. Excuse me. I think it's 8 minutes to get there and 8 minutes to get back, right? Am I wrong about that? Because it takes 8 minutes for it to come here, so it would have to be.
Yeah, I think
double, right?
Yeah, it's just over 8 minutes.
Okay, for it to come here, though, for it to come back this way.
One way is just over 8 minutes.
Right. So yeah, I don't know. For me, I'm looking at that 8 minutes. I'm like, well, hold on. Maybe we have the distance is wrong. Maybe we have the maybe the moves.
Maybe the speed of light is not known. Maybe the speed of light is not one of the most well-known things that we've ever done.
I would definitely say that.
Maybe. Here's the problem. We know the speed of light so well that we actually use the speed of light to define the length of the meter.
Who did this? Who's this?
That's the SI definition for the length of a meter, is the distance that light travels in a certain amount of time.
Well, I guess what I'm saying is, do you know when? Do you know when and what paper I go to for them establishing that? I guess that's the question I have.
So if you want to look at the early ones, that was Michelson of the Michelson-Morley experiment guy. He is one of the early guys to establish the speed of light, and I do believe that he. I'm not certain of myself now, but I think he got the Nobel Prize for measuring the speed of light. In the chat, if I'm wrong, correct me on that.
Okay, so this is the person who people go to for the ether experiment, right?
Yeah, the Michelson-Morley experiment that falsified ether.
Well, I don't know about that, but let's say this: when they did the experiment, are you saying that they got the speed of light from that experiment, or is it another?
No, it's a different experiment. Yeah.
Okay.
So now, since then, though, there have been many other significantly more accurate. So and I think that one of the early measurements of the speed of light was they had wheels, and they were on mountaintops, and they were spinning them, and something about getting the speed just right. So
wait. So you mean like something about the gravity on the wheels? It kind of affected them a certain way?
No, not gravity. So the wheels had a part that blocks and a part that's open, right? Okay. And it's spinning, and there's a light behind it, and then I'm a little too foggy. I read about this, and I'm a little too foggy on exactly how that.
No
but
problem.
Something to do with that gap, the width of that gap, and the rate at which it's spinning. They were able to measure the speed of light. And
I can check it out.
And better methods have been developed, but that particular method was very close to what we use today. So here we go. We got some of my corrections coming in. It says Ole Romer was the first to measure the speed of light according to Google. Professor Phil Bell says it was Michelson. So there it is. Okay. Yeah. So seems some confirmation, at least from Professor Phil Bell, that it was Michelson that measured it and got the Nobel Prize for that work. So So anyway, the thing is, though, the speed of light, in order to establish that the speed of light is not something that we know to a very high degree of precision, would require an awful lot of empirical evidence. The door is open. Science has a sign on the door that says, "Come in, and disprove us."
Come on in, show us if you can show us, right?
But it's not. Oh, I have this kind of rough idea about stuff. It's like, no, I'm sorry.
I didn't say that.
You're gonna have to, right? I'm not saying this, right? If you want to establish, if somebody wants to establish that the speed of light is different, the door is open, but you have your work cut out for you. You got to do better than the existing stuff, or show where the existing stuff is wrong.
Now, I'm gonna tell you right now, you're probably gonna think I'm copping out when I say this. When I actually do find out that answer, that seems like one of those answers that's just a little too much to let out. I don't think people do well with, I don't know.
Total opposite. If somebody were to figure it out and to falsify it or show that it's wrong, they get the Nobel Prize.
So you've never seen in history where people go against the standard science where things go good.
Really?
I've never done that one. Okay, show me. I'm like, well, wait a minute. Every time people bring stuff up, people get mad.
Vera Rubin says, "Hold my beer." I just had this up in the last stream. This is the paper written by Vera Rubin, a lady in cosmology or astronomy, a tough field for a lady. And the reason why she did it is interesting because the all of the things that people the good jobs in astronomy were taken by guys. The easy stuff, the stuff that everybody wanted to do. So she's like, I'm gonna do something that's just not people are working on. So she measured the rotational speed of galaxies and found that they did not match the predictions. This was a hard thing. She came to the door of science with, "This is wrong," and turns out she was right. It was wrong, and dark matter is what came out of this initial paper. But
Okay.
she didn't get a free pass. She didn't get a walk in and say, I'm going to chuck everything off the table because I have some vague idea. She had to
Of course
do the
not.
work. She had to
Right.
she had to be very particular. She had to do a better job. And she did a better job. She did a great job.
Okay. Okay.
So, all right, we got from Mark Beiser for $6.66 says, the fact that when the sun and moon are up at the same time, you can hold a ball next to it to exactly replicate the moon phase destroys his idea. Now, have you ever done this?
I really don't get what you guys say about
Okay.
that. I don't understand what you mean in preciseness
So-
about that.
So if again, it's triangulation is at the root of this, right? If you look at the moon, from you to the moon to the sun, that makes a triangle, right?
Mhm.
And the angle that the light is hitting the moon is a particular angle based on that relationship. Now, the distance between you and the moon is very small. So the triangle has a very small adjacent side, right?
Okay.
And the other one is very long and the hypotenuse is very long. So the
Okay.
opposite and the hypotenuse are both very long and almost the same length, and the short length is very, very short. So if you hold at arm's length and you put a ball right next in your vision, right next to the moon, the angle that the sun hits that ball and the angle that the sun hits the moon
They were the same.
are extremely close. So close that we can say they're close enough to treat them as if they're the same. They're not exactly, but they're close enough.
Mhm.
And if that's the case, then the shadow or the phase of the light hitting the moon and the ball should be the same. And if they're the same, then that tells us, that confirms that the hypothesis that we have a triangle that's got a very short side on one and the other two sides are very, very long. Then you can do a hypothesis for the flat earth. You can say, well, the moon is above the flat earth, and the triangle that I make between myself, the moon, and the sun is not this super long on two sides and super short on one. It's much larger, and the sides are closer to the same length. So you would not predict that the shadow cast on the ball that you're holding and the shadow cast on the moon would be that close. So you test that and you say, oh, they're the same, essentially the same. That falsifies the hypothesis.
Okay, so here, let me try this. Let's say you have a quarter moon, just say around. So, I mean, well, no, let me change that up. When you look at the moon, it looks like that crescent. You have the crescent on it. If you're in the middle of the day, I'm not exactly sure what people mean by that, though, because if I'm in the middle of the day and I have a ball out, the ball's gonna have different shadows throughout the day based off of how the sun moves.
Yeah, but the moon, or the moon also has a slightly different, because the orientation changes. If you look at it from your spot and you look at different times of the day, the orientation of the moon changes. This is a good one here from Genju Hauman. Says, actually, we can only measure the two-way speed of light, so it might actually be infinite in one direction. And I yes. And Veritasium has a fantastic video on that. The thing is about that I need to address, that is it doesn't change the overall measurement, right? So the point is, if light traveling away from, if we shine light or a laser on the moon and it bounces and comes back, if the light is faster going away from us and slower coming back, we don't know if that's the case or not. All we know is the round trip time.
Right.
But that doesn't change the actual distance measurement of the moon. Because if it's not the same in both directions, we've done the other experiments to know in all the different directions that if it's X percentage faster going away, then it's the proportional correct amount coming back to give us, to act as if it moves the same rate in both directions. So the other thing about it is there is while it's not something that can be or has not yet been empirically confirmed, it's the kind of thing that people don't actually doubt because it doesn't match things. But it could be wrong. The door is open. There you go.
Right.
So yeah, he says, Genju Haman says, I was going to qualify that. Absolutely. It doesn't change the actual distance measurement. And it's, here's why. If you know Quantum Eraser, do you know him?
A little bit. I kind of heard the name, yes.
Yeah, he's quite a horrible guy. He tried to do an expose video on me, but it just showed he doesn't understand things. And I have cited in the past that we've measured the distance to the sun by bouncing radar off of it. And he says, as his attempted debunk of that, he references the challenge that we can only measure the two-way trip. We can't measure one-way trip of light. But that doesn't change anything because we still know the distance. If the speed of light is different going away and coming back, it's proportionally the same, so the distance measurement is still completely valid.
So what was it? Was he just throwing a monkey wrench into the situation? Like, what was the point of bringing that up? Is he saying there's an alternative?
Because Quantum Eraser doesn't actually know much about science. He sees something, he gets kind of a better idea than a lot of people, but by kind of throwing around these things, he can, I think, appease his audience because they're never going to look it up. They're never going to look at the ramifications of it to see, well, does that actually make a difference? They're just going to say, oh, he did a video with lots of mean words towards MC Toon. And they're I have a video I'm preparing in response, and I actually cropped out into a montage. It's a 20-minute video, and I have a montage of just his insults, which is around 10 minutes, I think, maybe a little less. I didn't include them all because it's too long for a video to just have his montage of insults. So,
but now hold on to him. Let's be fair. Are you telling me you wasn't calling him no names before he made that video?
I have called him a monster.
There you go.
And a horrible person. And I stand by that, and I think anybody that knows him will probably not have any problem with those adjectives. So anyway, but if you look at his channel, everything on his channel is the same. In fact, I have a book, this book here by Danny Faulkner, Falling Flat, right? Danny Faulkner never addressed anything towards QE before QE did an insulting video on this book.
Is that like, it's why in that book, are they saying 9.8 meters, that circle is coming up at 9.8 meters per second or something?
No, this is not a flat earth book.
Okay.
This is a flat earth debunked book.
Okay.
Right? That Danny sent to me. He even signed it. There it is. So as far as I know, it was completely unprovoked, but he still does the same type of stuff. So,
well, I think a lot of people, I think this is both sides, to be honest with you. I think a lot of people, once you start, this is why I said, once I start figuring out the information, I'm probably, even though you showed me the lady, and I appreciate that, I don't know if I'm coming forward with certain information, because it seems like people are so entrenched in certain ideas that once you start saying, what about the possibility of this? What about if we, what if this is switched up over here? People tend to lose it. They tend to not just sit there, go through it, let's particularize it. Let's see where it could be wrong here, there, or possibly right here, there. They just kind of, that's okay. That's not what I know. I'm good. So it happens both sides, I would say. I see it on both.
I agree. But, I think the amount that QE dishes out is disproportionately larger by far. So it shows his character. He has, it really shows QE's character. That is his main form of communication is to start with at the bottom with insults. So
you flat out, so I'm with you, QE. You got it.
Patrick Butler, again coming back, he says radio waves can't wrap around a ball. True.
Hey, hey.
Yep.
The man's dropping dimes out here. He really is. He really is. Oh, you know what's funny? I never realized the moon rocks back and forth the way it does. I think that's where we got the song "Rockabye Baby" from.
What?
I just realized
runs back and forth.
No. I just realized that the moon rocks back and forth.
Explain.
I saw that with it was on the Shields debate. Mr. Sensible was talking to the guy you talked to, this guy too, John R, I believe, or JR.
Joe Redmond.
Joe Redmond, right.
Yeah.
I think he changed the Joe R as JR something recently with Mr. Sensible. But Mr. Sensible gave a video and he had the moon. It was like I like, oh, I never noticed that. And they had to just rock him back and forth.
Oh,
that's interesting.
The libration, it's called.
Libration? Is that what I heard?
Yeah, not libations.
Right.
Libration, yes. Very close.
Okay. Ooh. So that's what I'm saying. I think that's where we got the song "Rockabye Baby" from. Looking at that movie.
I would okay, maybe. But the thing is, I don't think librations have been easily put into a sequence like that until long after the song was written. But could be. Well,
I mean, but obviously the way it was, you can see it immediately. Yeah. I mean, but that's why I'm not like, oh, okay, I got it.
King Crew is not drunk enough for this. There you go. Tip it back. The moon knows math. The moon falls out of trees now. Yeah, Rockabye Baby is all about about crib death.
Is it?
Man, you brought it dark.
Dang, for real? No, you sure it's not just you saying some stuff? Like, wait a minute now.
No, actually, I do recall that seeming right now. So, all right, K Opossum for $5 says, just throwing money at you because I can't remember if I've already done it or not. Well, thank you for throwing money at me, K Opossum. Oh, and you know what? He's an Australian.
Is that right? Y'all gonna finally get it going, huh? Y'all gonna finally get it going. All right.
Yeah. I've been wanting to debate him for a long time.
Yeah, my boys gonna smack you in the butt a little bit, right?
What's that?
You know my guy's gonna smack you in the butt a little bit, right? You know they're gonna give you a little bit.
You think Tony is? Oh,
Tony's one of my dogs. One of my dogs. Yeah,
he's a pussycat. Come on.
No. And where are you doing Shields or on your channel or what?
It'll be here.
Okay.
And we've set a format. Actually, we're going to use my my 4-topic format. I'll put in the chat for people to look at. I like it. It's you present for 5 minutes, you have a rebuttal for 5 minutes, and then 10 minutes to discussion. And we do that 4 times. So
okay,
that'll be good. Yeah.
See, he gonna hit you. I'm like, okay, like in this case, like I've seen him hit a few. He's hit a few hitters, and the responses he gets back is just like, yeah, exactly. People they just don't want to deal with it. They're just like, okay,
yeah.
Well, you didn't.
I gotta say, I mean, most of the people I debate here, Keith, are pretty easy. Like,
see, there you go.
I don't prepare anymore. I don't.
Oh, me either. Yeah, me either.
Well, maybe 5 or 10 flat earthers have like prepared. For the most part, flat earthers don't prepare either. They're just like, oh, I'm so confident. I'm just gonna basically repeat the same. We can see too far.
I don't know if it's that.
Can you show me where we can see too far? Oh, there's a video by somebody. Okay, that doesn't help. Anyway, so that, and he just messaged me. He was like, can you send me the Zoom link, please? And
he wants to come in. You can come in if you want to.
As a thumbnail, please use this. No, I mean for tomorrow. So.
For tomorrow, gotcha.
Oh, here he says, Forbes, scientists admit embarrassingly, we don't know how strong the force of gravity is. It's a little bit of a straw man.
But that's his thing to you?
That's the thumbnail he wants. So.
Oh, okay.
But I mean, he's used that before on Facebook, so that'll be good. He has. Sorry, I'm reading. Professor Phil Bell is talking to Gary Wybenga saying, "Let's make it happen." Gary, come on. Gary, Gary, I will have you and Professor Phil Bell do it, and you send me a format, and I will just run that format. So there it is.
Gary, all you gotta do is give the observations like I see you give sometimes, and let's just hear what he says to it. It is what it is, basically.
Yep, I guess. So people are giving Gary crap. Rightly so. Come on, Gary. Oh yeah, somebody said, was it because of the two-way distance was, I forgot the guy's name because I can't hardly pronounce it. There it is. Genju Hauman says, I was trying to say that if I heard a Flurf actually use that in an argument, I would at least give them a little respect rather than their evidence being, I can see it's flat. QED. So yes, it's a better argument than just it looks flat, right?
I gotta say though, there's an interesting simplicity to the argument. I mean, it's basically like, hold on. As I look out, as I see, I just see this. I don't. When I go to the ocean, I don't quite see this curve that you're telling me over here or over there. And then you tell me this boat is over the curve. How did I pull it back?
And
I mean, it's like those types of things.
That's why ancient cultures would have thought that, because they didn't have the things we do now, right? So here's the easy thing, right? All those ancient cultures, what did they think the sun did at night?
I don't know if that's really true.
I think that's
modern day interpretation of it.
Oh no, it's in the Book of Enoch. It's in Greek mythology and Roman mythology. It's not our interpretation. What did they say? What did they all say?
Well, hold on. I'll say this. I think when they say things like the sun going under the earth, they just mean kind of like, how to say this? They mean since it's out of their vision, it's now going through a process where it's, say this, it deals with spirituality. It's gonna be hard to explain it, but it's almost like a rebirth. It's like it's going through a process of, I don't have the exact words for it. But anyway, what I'm saying is that when we look back on that stuff, I think they have a certain type of poeticism that they're talking about it, and it's not necessarily direct. Let me put it that way. It's not like, that's actually that.
And Keith, I thank you very much. I will be covered for my entire family for breakfast for that heaping pile of waffle you just gave me. I'll just make sure that we have syrup. Pure maple syrup, not that fake stuff, is what we put on our waffles. Okay. They said it went through tunnels. The Book of Enoch calls it portals. That's their explanation for where the sun is at nighttime. It's going through a tunnel, and it's very clear especially in like the Greek and Roman stuff. Like, it's a tunnel and then it goes on a chariot and it brings it to. Anyway, they did that because they did not know and could not know that when it's nighttime for them, it's daytime for somebody else. Right? If the fastest way to get somewhere is to walk there, ride on a donkey, or take a boat, by the time you get somewhere else, it's days later. So you don't know that nighttime for them is daytime for you, right? So they didn't know that, but now we do. And the sunset doesn't have an explanation, so you don't need any math for that. There's no sunset.
Yes, you do. That's when we go back to that refraction. You do need that math for that, because that would explain how it could happen.
but the refraction necessary for that is two problems. The other direction then is known to refract, and number two, an incredible amount more than has ever been measured in atmosphere.
I mean, like I said, I have to go over it. I got to get into the details of what they're saying and go from there. But yeah. Oh, now, real quick. Now, okay, going back to the Greeks. Like, okay, when they said, Apollo and the chariot and the sun, you really think they actually thought it was a chariot?
I don't think they actually thought it was a chariot. No.
Yeah, that's my point. So even when they explain other things, it's in the same way. It's not direct. It's just giving this format, almost allegorical, I guess, but it's just giving a format so that you understand certain processes. Because when the sun goes away, even on flat, When the sun goes away from us, it's going through a certain transformation. So wherever you are locally, when it's 3:30 your time, hear me out, Tim.
Wait, it's a transform. Is it an Autobot or a Decepticon?
Both. So as it goes around, when 3:30 hits at your time, I know you're not into this type of stuff, but I just let you know. Around 3:30 a.m., anybody's time, there's new energy hitting your area. And that's about 2 to 3 hours before the sun is going to get to, in general, for most people, for when the sun is going to come up. That's going to be about 2 or 3 hours before the sun gets to you. So that's going through a whole lot of spiritual and, other world type of stuff that they're talking about for what's happening as the new day comes around.
Okay, and new energy, how is this quantified? Is this in the form of photons?
I mean, if you try to do with the materials you know of, I don't know. I mean, it probably possibly can. That's why I have to get into it more to say, okay, no, they actually found it right here. They just don't know what it is.
I don't need more waffles for tomorrow.
Hey, man, I mean, it's what it is to you. Ain't nothing I can do about that.
Oh, okay. So NANA for $6.66 says Gary Wybenga is a coward. Hail Santa. I don't know why he likes he likes Santa a lot. He's like Elf in the movie Elf.
Yeah.
Okay,
let's be honest. I mean, when it comes to this stuff, it's just been 5 years, man. We're just getting our feet wet. We're just really we're just now getting because even right now, I would say within the past year, things have changed. It's not the same people as it was in the beginning. You are getting a little bit more math out of people now than you did at first. Except for maybe there was an attempt by Dubé, I guess, right? Because in his book he has a few mathematical. No, you wouldn't agree with him, or he doesn't have anything math.
I've not seen his book, but I've seen his video, and nowhere in his video does he do any math.
I think he goes over a little bit of trigonometry.
I'd be very surprised to see a flat earther actually apply trig.
I do it all the time, Tim. I do it all the time.
Yeah, but do it now. Let's see it. Let's do it. Let's test something. What?
Here we go. What you got?
No, you. Something that you've done that you can go over, that you have the depth that you've already prepared, right? Because why are you laughing? You don't need to laugh, right? Because this here. Are you prepared to talk about this?
Yeah, but you know where it's going to go. I'm going to say your vision is going to die out at a certain point because you're going to say it should be a negative angle. I don't know where that comes from. You're going to say it should be a negative angle.
Yeah.
We're going to say, nah, it's just that once it gets to a certain lower angle, then your vision is gone with it, just like the boats. And so that's why you don't see it anymore. Yeah,
but the thing is that I went over this last time you were on. I personally measured the elevation of the sun if the Earth is flat using this method. Mm-hmm. Right, and I got in twice a year. It's 3,105 miles from Minnesota, and everywhere else in the world, it's a different height. So that tells me refraction is at play in a way that we don't know. Oh. Well, let's put it this way. It's special pleating, though, is what it is. Well, let me put it this way. If it's flat and that is the case, then we have to go into the refraction and see how that works. Let me put it that way. If you go with the hypothesis of the Earth being flat. Okay, so then calculate the necessary refraction to make that happen and see if that type of refraction is possible by applying Snell's law to see what type of difference in an index of refraction gradient would be necessary. Right? That's what you need to do to test your hypothesis. So, but outside of that, special pleading. Are you still there? I'm here. Oh, okay. I'm letting you talk to smack. This is my special pleading card. I got the critical thinking card pack right here. And it just from let's see, from schoolofthought.org. They're not a sponsor of mine, though. If you want to sponsor me, schoolofthought.org, please do contact me. Email in the description. Special pleading is what it comes down to me, right? That you started with the the hypothesis is perfectly fine. Put together your hypothesis. Earth is flat, this. Here are the ramifications of it. We can measure the angle of the sun, and we'll get this. Okay, it doesn't work. Okay, adjust the hypothesis. Put into it refraction such that it can do that. Okay, what quantity of refraction would be necessary for that to happen? That's your challenge. Because right. That's the hypothesis. To come out of that comes your prediction. So you need to get that prediction together. And here's what we can be certain of, though. in refraction, which way does the light bend? Towards or away from the higher index of refraction?
I don't really. I mean,
these glasses, the lens on your camera, your eyeballs, every P900 ever made uses Snell's law to work. If it didn't, right, people understand very well which way light bends when it goes into a higher index of refraction. It bends towards the higher index of refraction. Always. That's Snell's law. It's a law. The door's open to disprove the law, but nobody's done it, and you have a high bar. Right?
Well, hold on. Let me say this. I don't even think that's what it is. When it comes to the way these things work between the two systems, I don't think it's so much one way is wrong. I think it's the way it's interpreted. That's what I'm saying. That's what I'm saying. You have to go over
together your hypothesis,
in detail.
But let me finish this refraction thought.
Okay,
right?
yeah.
So the higher index of refraction is nearer the ground because the air is more dense near the ground, and it's much less dense with increasing elevation. And you can see that with flat earthers' balloon. Dwayne Kellum has a balloon where he has a barometer on it, or I like to call it a pressurometer, right? Because there's two things. You got meters and applicators, right? So if it measures pressure, it's a pressurometer.
I'm sorry. Hold on. Meters and applicators?
Yeah, that you
applicators. You said applicators. You said applicators.
Two types of tools, right? This is the garage. This is my garage tool talk for you. My kids know this, right? So there's applicators and measurers and meters, right?
Okay.
So you take the thing that you're measuring, pressure, and then you just add meter to it. So pressurometer measures pressure. Some people say barometer, but it's much more fun to say pressurometer, right? So what's this thing? What's it doing? It's measuring.
What do you mean, measuring?
What's it measuring, though?
I guess you would have to determine that, right?
Length.
Whatever you choose to measure?
It's measuring length.
Come on, too. Yeah.
Making this a lengthometer. That's a lengthometer there.
Okay.
Right? And then, let's see, I've got, this one. This applies something. What does this apply? I'm going to apply something. Right, watch. What did it just apply? It applied a cut.
Force?
It applied a cut.
Okay.
It's a cut applicator.
Gotcha.
That's right. That's a cut applicator. I mean, you got to use the right terminology, right? I've got this one here.
Yeah.
Couple others. What's this? It's a twist applicator. And this, what's it doing?
Applicator.
It's squeezing. It's a squeeze. It's a squeeze applicator.
It's a squeeze applicator. Okay.
All right. So, all right. That's shop class is over. So, what was I saying? The pressurometer or barometer, if you want, in Dwayne Kellum's balloon as he went up, the pressure went down. Near the ground, there's higher pressure. Up high, there's less pressure. That affects the index of refraction. The index of refraction is higher near the ground, lower up high. That means that the light is going to bend towards the ground. Just in general, this is just a qualitative, not a quantitative observation. Right? We can keep it's going to bend towards the ground. Now, when light bends towards the ground, it makes distant things appear higher. Because Because for the light to come towards you, this that starts off coming towards you is going to get bent away and it's going to hit the ground before it gets to you, right? So the light that's going to get to your eyes has to start going higher, curves around and comes at you, hits your eyes at an angle such that you're going to look that way and it's going to appear that way instead of where it came from. So I have this on my website if you want to look, people. That's what refraction does. It makes in the air, makes things appear higher, not lower. So in order for the sun to appear to set due to refraction, the air or something would have to cause the index of refraction to be higher as you go up instead of lower as you go up. The opposite. And not just a little, though. That's the thing. Because in the air, the amount of refraction that you can get, it changes it by a couple degrees, and that's it. But in order for the sun to set, you needed to change by a drastic amount. So the challenge to you then is first to do the math to figure out what that is, and then find the physical, plausible mechanism for how it's happening.
Okay, hold on, one thing. Now, you always talk about the sun and not setting. Now, we know of a certain situation, especially in the Northern Hemisphere during summer, that around the North Pole, that sun will not set. So everything that you're saying, that right there's where it applies. But that tells me the distance.
For part of the year.
No problem.
Part of the year, right? So
no problem, but hold on.
In June, north of the Arctic Circle, the sun will, right? So it's going to
do a sine cosine curve movement, right?
Yeah.
It's not going to go fully down, but it's
here's
going
the
to
deal.
do that up and down.
You don't need it to happen sometimes. You don't need the sun to not set every once in a while. You need the sun to never set. Because as far as I can tell, because I haven't seen a flat earth model that explains it. So everything that I know about physics, everything I know about how light works and how everything works, suggests to me that if the earth were flat, the sun would never set. Ever.
Granted,
it would never set. So one time of the sun setting is a problem for flat earth. Maybe it could be explained by some anomaly. Maybe there could be some refraction that one time. But it happens every day between the Arctic circles and the Antarctic circle. Every single day. So 7.5 billion people every day see the sunset. That's 7.5 falsifications of flat earth every day.
So this is what I'll say to that. So the reason I'm bringing up that we see what it does in the summer is that what I would do is when it's really low, from there I want to start kind of moving back in distance and in length and try to figure out, okay, at this point I can't see it. So that would tell me this is about how much light, we'll put it this way. The sun gives out whatever, 6,000 miles worth of light or, 5,000, whatever it is. That would give me how much that candle light is pushing out. I'll say it that way. That's why I would go to that. That's what I would be.
How many lux?
Yeah. Well, whatever the
SI units for light.
Right.
Candela, actually, not lux. Luminous.
Is it called candela too?
It's candela. Yeah.
That's interesting. See, it is. See, there you go. That's the stuff I'm saying about secret language. But for those of you that don't know,
language.
For those of you that don't know, I am Gnostic, so we do claim to have certain secret knowledge about God and all those types of things. But in that language, in the professional scientific books and stuff like that, to call it that's because they understand, like me, it's a candle and it has a certain limit of light. It's not just forever. I would say that. Let me put it that way. I would say that.
It is, yeah. If you look at the historical, it's based on a candle. So yeah.
Yeah, I agree.
But
the one in the sky,
like other things. So if you look at the meter initially was based on the distance from the North Pole to the equator.
Okay.
That was the first measurement that gave us the length of the meter. And over time it's changed. The distance has not changed by much, by tiny amounts. And most recently, the SI units have been reworked and they are 2-3 years ago, maybe it was like I'm gonna look it up here. They redid everything.
They have a new like standard now. Okay.
Yeah, so they redid it, and so the idea is you want to be able to take things that are, say you found yourself on another planet and you didn't have any of the technology that we have now, and you wanted to somehow over time build up to know this, to have the same basic units, right? So if you knew that a meter is the amount of distance that light travels in a certain amount of time, well, then all you need to do is have the ability to measure that distance and measure time accurately, right? So it's based on these physical things that are hopefully the same everywhere in the universe, at least I think so. So that they redid them instead of being like,
probably not.
so I joke about Scottish sheep units. That's units based on sheep. So the unit of sheep unit length is sheep length, which is how long a sheep is. Now, how long is a sheep is different based on the sheep. It's a ridiculous measurement. And I intentionally make it a ridiculous measurement to show the actual awesomeness of the SI units. But if you look at Fahrenheit is, he did a pretty good job. Fahrenheit 0 is the lowest temperature he could get with salt and ice. That's 0 Fahrenheit.
Right.
32 Fahrenheit, no reason for 32 Fahrenheit to be water freezing. It's not based on that at all. 100 degrees Fahrenheit, I think it's not accurate, but it's well thought to be the internal body temperature of a cow. So here's the deal. Mr. Fahrenheit was trying to communicate temperature measurements with one of his colleagues somewhere else, and he's like, well, everybody had their own scale. Like, here's how I made my scale. I took ice and I took salt and I mixed it, and I mixed it and it stopped going, and I put a mark on there and I said, let's call that 0. Then I took it and I shoved it up a cow's rear end and I marked 100. That's to me, that's the humor of it. Anyway, the internal body temperature of a cow is not a great universal way to measure temperature. So they did not use that for Celsius. Do you remember what Celsius is? Do you know how they determine Celsius units?
Well, which one was first, Celsius or Fahrenheit?
Fahrenheit.
Shoot, I guess all I know is that 5/9 conversion number right now. I don't even have it fully down.
0 Celsius is the temperature that water freezes. And
I thought you said something else.
Yeah, that's Celsius. 100 Celsius is the temperature that water boils.
That it boils. Right. Yeah. Right.
So that's based on, here's the problem with that. That's based on the pressure at sea level. It's not very universal, is it?
So it's more so talking when the pressure's at a certain level, then these
things so that would not be a useful piece of knowledge to establish 0 and 100 if you're on a different planet, because the pressure would be different.
Granted. Right.
So the SI units initially was based on that, and they have updated them so that they're not based on these arbitrary things.
Okay, it's a little bit more universal based off whatever the pressure is.
Yeah, and I don't remember the temperature. Temperature is not one of the fundamentals in the SI anyway. So, all right, and all right, Kelvin. You know Kelvin are not Kevin, Kelvin.
Right. That's another version of it, right?
That's another temperature. What's Kelvin?
I don't know. I don't know the number for kelvins on when it's freezing and hot and boiling and all that. I don't know that.
All right, 0 Kelvin. 0 Kelvin is absolute 0. There is nothing possible to be colder than 0 Kelvin.
So that's supposed to be when molecules are just dead stopped, right? They just don't move at all.
Everything in a molecule, right? So it's It is, that is universal. And so then I'm sorry, that is part of the SI units. 0 Kelvin is that, and then the 1 degree Kelvin then is about the amount of energy that it takes to increase 1 degree of a cubic centimeter of water. There you go.
Okay. So you just have to then extrapolate it from there.
Well, it uses centimeter, which is based on the speed of light. So there you go. So I think you only need to know 7 things, and then you can get all units from there.
Okay.
So people have done that. People have done all this hard work, and then yet there's people that think the Earth is flat.
Well, I mean, see, that's where you guys go too far. I mean, yeah, let's establish that people have done hard work. I don't think anybody denies that. There are other people who are saying they possibly got it wrong. That's all.
Yeah.
That's it. People don't have to start going into their well, I mean, I know because of what happens between the two sides and all that, but you really don't have to go into somebody lying or this or that. Hey, they're just honestly saying, I think it's this. No problem. I see something else. That's all.
And that's fine, but to be an honest, scientist, right? You get your hypothesis, you do your stuff, you work through these things, and if you get to the end of it and you're like, hey, that falsifies it, it doesn't work, then an honest scientist is like, let's throw that away and go somewhere else, figure something else out. So there's no flat Earth hypothesis that I've seen ever that passes.
I mean,
that's the
point,
problem.
I'll grant that. Yeah. I mean, to this point, I would definitely say, yeah. I mean, nobody's presented anything where you guys can go over and really meticulously go over the math and the numbers and all that to really analyze.
So then, Keith, why would you still think that the Earth is flat?
Well, I mean, that would be. See, here we go with that. Okay, look. So
I mean, you granted. Hold on, you granted a huge thing there.
Yeah. I mean, sure. Why not?
So, why do you still think the Earth is flat?
Because you still have to understand that in this process and the things that they're going over, they are still told things from the start, and there's certain assumptions that they're holding on to from the start. And we're so down.
Okay, like what then?
I mean, I don't even think off the top of my head, but I mean, any type of experiment, there's going to be certain things that you do kind of hold as an assumption, or that you expect might be an assumption in this. I think this is the case, so I'm going to assume that this would happen. Let me put it that way. I mean, there's going to be some assumption.
So it sounds like you're an axiom is what you're describing. An axiom is
explain that, please.
Like a fundamental thing that you accept as true, and you can't establish correctness or incorrectness either way, but it makes sense, and you just accept it.
Well, not for the. Well, what you're saying? FD people do that?
No, an axiom is just a universal thing. So let me.
Something accepted, right? It's kind of universally accepted as something that's just part of it, right?
Here we go. A statement or proposition which is regarded as being established, accepted, or self-evidently true.
Okay. So I'm focusing more on the not so much self-evident, but the for scientists, I would say for the establishment, we've been through so many years of science that they've already established that it should be X, Y, Z. Yeah. This is where I went back to. I think in general, people aren't going to argue against the main.
Yeah. So it goes to standing on the shoulders of giants.
Right.
And not you could if you couldn't use stuff that other people have done, you'd have to start from zero, and you couldn't use measuring devices that other people did. You couldn't do. I mean, you couldn't do anything. You'd be like the guy on a new planet all alone to do science, right? So everybody uses something that somebody else did, even if you're just measuring length. The length that you're using was established by somebody else. So you're true. But everything is built on something that somebody else did, or you have to start from zero, and you won't get very far before you die. Right. So, when we do things like the length of a meter and how fast light travels, right? Those things you can call into question, and you can find if they're wrong or not. But but we take it, if you've not done that, you kind of take it as an axiom, I suppose you could say, because you've not personally done that from zero.
You didn't go, and that part, that's what I'm talking. That's the part right there. I don't know about zero, but what I do think that flat earthers should do, go over all of these experiments that established everything up to this point. Go over those things.
Absolutely, perfectly fine.
Right.
And here's the thing. When you do that, you will find what? That they're correct. You're going to find that they're correct. You will not find an error in the speed of light. You will not find an error in the experiments that measured the strength of gravity. You will not find errors in all sorts of things that would have to be errors in order for the Earth to be flat, right? So like your refraction thing, Snell's law is pretty strong. Could it be wrong? Sure. Big bar to show that it's wrong. So showing that Snell's law is wrong, and it would upset everything included with optics to show, and
there you go. See?
Glasses and right, all of it would overnight be completely shook up. How could you explain these things if Snell's law does the opposite of what we think Snell's law does?
And it may not be the opposite. Again, that's why I keep going back to it.
But it would have to be the opposite. It would have to be the opposite in order for the sun to set, if refraction is what's happening.
Maybe it just needs to be adjusted to the side a little bit. Maybe it doesn't have to be overhauled. Maybe it's just a few tweaks into it or something like that.
But like I said, I went over that. The way that refraction works in the atmosphere and has been measured is that it causes distant things to appear higher. In order for refraction to cause the sun to set, it would have to make distant things appear lower, meaning that refraction would have to work the opposite way as everything that we've ever measured, and work the opposite way of the way Snell's law says it would. So basically, you would have to show that Snell's law is the opposite in order for refraction to cause the sun to set.
Well, I'll tell you this. Here's something that's hitting me intuitively just out the gate from what you said. Okay. I would look for, based off of the angle of degree that the sun is over me, whether is there a possibility that Snell's law changes from 90 degrees to 30 degrees? It could be a difference in refraction between those, as opposed to once things start getting below 30 degrees, maybe things kind of flip up to the side. That type of stuff. That's what I mean. You have to go over that stuff. If we want to change, if we want to say something different, that's what I mean. We just have to kind of go over it meticulously, go through it, give the numbers. I still contend with you. I'm not touching it. Once I find out what it is, I don't think I'm touching it, though. I'm not giving that out. It's like, all right, I found it out. That's all I need. But, when it comes to flat, like I said before, my main leaning on why I lean that way, it is my religious belief. It is the fact that I think, I go with the fact that I think this was flat and it was this way, and I think he did it that way. Hey, when I go to the other side, if I find different, I find different. But I will lean that way. And so in my leaning, I'm going to go towards these tests with the flat stuff probably being where I would think. Now, as I get stuff wrong, I got to go over that. Wait a minute, hold up. How come I didn't look that well? How come I did this? I mean, it's meticulous work. It's not a week's work. I think this is a lifetime's work that you have to go through if you're going to choose this road to make it true to yourself in actuality, and not just I think it's that way. But the road to really get to that truth of it, you're going to have to go through. That's a lot of university studies you got to go through. I'll say it that way. And I don't think anybody's really qualified for all that. I mean, even PhDs, they have a PhD in their particular area. You got 1,000 other PhDs in other areas. So you have all this knowledge, and that all that knowledge they have is just not even a speck of dust compared to all the knowledge.
Absolutely. So the thing is, though, you're standing on the shoulder of giants, and you go to that other PhD that's the expert in Snell's law, and you're like, could it go this way? Could it do this? He's like, I've never seen it. it would require,
Right.
what would it require? And knowing what he knows, he'd have to do this, right?
Right.
Everything would have to work differently. Physics would have to be re-explained, because these things they don't sit in isolation. Snell's law is not independent of other things, and Clive Wells has made the point here that you can derive Snell's law from Maxwell's equations.
Now, what's Maxwell's equations?
Maxwell's equations deal with electromagnetism, and light is electromagnetism.
Right.
So they're related. And so it would not just affect one thing, right? They're all these things are meshed together. So somebody that knows well about optics and Snell's law, somebody else that knows well about electronics, and somebody else that knows well about electromagnetic transmissions through different mediums. All of those mesh together and agree with each other. And if Snell's law was wrong, it would affect all of them.
Okay. I don't. All right.
And so that's why I say the bar is high. The door is open, but the bar is high to find the error in it. So.
Right.
Caucasian Sensation, hold on, says, well said, the line of lying is crossed when flirts refuse to follow logical analysis, discussion, and refuse to be led to the other's point.
That is a personal issue of confidence that you need to get rid of. Another person's view is another person's view. To need them to come to your view is weak.
I don't think that's the point. I think the point is that evidence is shown, and things are, science isn't objective. It's the point of the process, and the things that people put in there is to remove, it's not subjective. It's to remove subjectivity, right? So it's not.
It's an attempt. It is an attempt to remove subjectivity.
Yep. So it's the best we've done, and the peer review process is meant to shake out those things. So somebody really wants their thing to be right. They have an idea, they really want it to be right. So they do an experiment, they write up something. And then they send it into a journal, and the journal goes and gets some people to review it. They're like, hey, this is wrong. They send it back. Now that person may say, screw you, I'm still right. But they don't, they're not getting, they're not, they can try. Absolutely. And Vera Rubin, right? She did this. She came back and she said, hold on a second. All right. Maybe the process was like they had good points, and she's like, yeah, I didn't do enough work on this particular aspect of it, and then she did better on it. But at some point she got it through, and people like, I cannot find fault. That's good.
Right. Now I was about to go back to that. Now, when she first gave her paper, they did reject it, right?
I don't know the specific history of, she sent it to this journal. She did I just know that she had a difficult uphill battle, to getting her observations through, and people were like, nah, I don't think it. I won't accept that. I don't take it. Right. And so what it did though is it made her better. And so when she did it, what's that?
For what they wanted, it made her better to explain it in the way that they needed.
She had to come with better than she had initially, because there was a lot of things that the existing stuff was set on, and so it upset a lot of things. And people sitting at the top of their career after many years of doing things, it was a threat to them. Absolutely. So yeah. So it did, and she was well rewarded for it. But if somebody's going to say, hey, Snell's law is wrong, okay, show. Nobody has though, right? And your position is, for my presumed flat Earth to work, Snell's law has to be different. That's kind of just a vague idea, right?
Hold on. Let me get in here. Hold on. So here's the point, though. The reason why that last statement is incorrect, the reason why that last chat is incorrect, the super chat is incorrect. When she had a view, she had a thought, but when she first gave it to him, yeah, they said, "Oh no, this doesn't work." Now, based off of that statement, when they told her it doesn't work, she needs to shut up, go home, and leave it alone, because they already told you what's what. But that's not science. That's not innovation. It's not about just listening to somebody tell you something. You got to go through there and get in there. So that's why I'm saying it's weak to have that as an opinion. It's like, no. But you just got to go and get at it. If you finally see that it does not equal up that way, but they still do, leave it. It's what it is.
Here's the deal. This is what she came out with. This isn't a vague idea. This is deep analysis of what happened.
Right. To the point to where they could actually understand a little more probably what she was talking about.
Yeah. So if you think that refraction causes the sun to set, do that level of work.
Right.
And if at the end of that work you're like, "Yep, I showed it. Here you go. Send it to me. I'll look at it. If you're right, I'll back you. Right? I don't think you will, but I think I'm pretty safe in saying this, right? But I think what will happen is one of two things. One, you might just leave it as a vague idea and whatever. Or you might get into it, start trying and testing out what would be necessary, and then say, "Oh, yeah, that didn't work. Let me move on."
There's a third option of, let's just say for some people, like when she first gave the paper and they rejected it, obviously that paper went through. So maybe there was some issue at first with the paper, but obviously she actually got it to where they understood what she was talking about. If you have somebody else and they say something and you don't understand what they're talking about, the first time they send that paper back to you, you might say, "Oh man, forget it. They don't know what they're talking about, whatever. I'll just study stuff on my own and learn it on my own, and so I know." But they just not gonna know. I guess they don't get this good genius because they choose to reject it. It'll just, some people will take that route. That will happen. And that's where secret knowledge comes from.
All right, I'm going to read from Caucasian Sensation. I think you already responded to it, but Gary, this is to Gary. Gary, Flurfs come here to debate on something that everyone on Earth accepts and verifies. That's a bold move for someone with confidence issues. So let's see what Gary said to prompt that. See if we... Yeah, Gary. Poor Gary.
What, you jumping on somebody in the chat or something?
Oh, it's Gary Whitebenga.
Destroying the chat.
Let's see. Call it whatever you want. It makes the light become more and more dim even before it sets. Oh, he's talking about the light going through the air. Yes. It does reduce its brightness and it diffuses it as it goes through the
atmosphere, right?
More significantly more length of atmosphere.
Right.
Now, Atlas 6355 thinks that you're trolling me.
Because you guys don't want to believe that anybody in flat Earth deals with math or really believe in space. Like I said, it's only two of us as far as I know. But I bet they do believe that.
What, there's two of you that do math?
Well, I would call myself the math guy, but I'm talking about space with effed up world.
I haven't seen you do any math yet.
You sure have. You just rejected
Do it. Show me the math.
I did it with the sun, but then you brought up yours with the sun. You said, "Well, why is this a different?"
No, you had a
different number.
You didn't do any math. You just had kind of a rough idea.
Oh, I did the experiment of Eratosthenes on a flat world again. All right, whatever, man. It's on the one. They can go check the first time I was on. That's when I did it. Whatever. Well, I'll tell you what. When I make the channel, I'll give you direct on this video. Like, all right, here you go, Tom. Here it is. Now what?
What is your? Why do you have to wait to make your channel?
I want everything right. I want the. You got to get that little ring light. I want to do a little more. I want to get into the programming, so I'm not coming on and things are messing up. You know what I mean? I want to know how to get into the things. All that.
Because you want to. You want to do live streams, or you want to do pre-recorded videos?
First it'll be pre-recorded, but I do want to do live stream as well.
Yeah, okay. Well,
I'll do live stream.
I'll tell you.
People I can talk with.
I'll tell you the same thing I tell everybody else. Just do that first video. And if it sucks,
Right.
then a week later you can take it down. But you don't know.
Right.
You don't have the skills today that you will have a year into it to make the video that you have in your head. Right? You don't have the light, you don't have the software, you don't have the skills, you don't for doing all that in the software. You might not have like how to put together a video that's intelligent and flows well and all that. That takes time, and none of us had that day one. So if you wait for that to happen, you'll never get to day one.
Well, no. Like I said, I'm just talking about knowing how to do. Well, let me ask you this: when it comes to the programming software, is it pretty easy to go along with, and you know how to do this, that, and the other thing?
I am.
Is it user friendly, or is it? I
am a software engineer. I've done it my whole career, and never once never once have I had to do any software for this. Never.
Right. So my point is that it's user friendly, correct? It's not something that you have to really be deep into.
Yeah.
Computers to really work.
Exactly. Yeah. So
okay, that's what I'm saying.
If you have,
I thought they were. So I mean, if they're not, yeah.
If you have a Mac, use iMovie and move up to Final Cut when you're ready. If you have Windows, use whatever. Filmora is a good one, I guess. So
okay.
All right. Let's see. Okay. So Caucasian Sensation said, I read the name Gary in the chat and accidentally typed it in my previous super chat. Here's $5 to our guest for getting his name wrong. Okay. So Caucasian Sensation says, correcting now the previous chat, is Keith. Flurfs come on here to debate something that everyone on Earth accepts and verifies. That's a bold move for someone with confidence issues.
So let's say this. For anybody out there in the FE world that always said, they're not lying, people, they're just not speaking. But anybody out there that says you have certain groups that are not telling us the truth, why would they want to deal with this? You have people that can't get past a certain level of critical thinking, and they're going to say, no, they said. So why would you argue that? It's just, okay, let me go about my own way to see for myself if it is true or not. And, one more thing, too. For a lot of you out there, FE, too, if y'all really want the true nuggets and the good stuff out of this stuff, you don't really want to argue with the anti-flat earth people that much. You really want to focus more in on scripture and what this means and start getting into those other knowledge and understand what's out here, man. Yeah. These guys are going to be these guys.
Confront us directly with actual science. Do a hypothesis. Test it. See if it works. And if it doesn't, start over. Adjust the hypothesis.
Right.
But all of, with a few exceptions, all the flat earth channels, all they do is try to address the globe, and usually it's a straw man of the globe, and then say, oh, I disproved this straw man of the globe, therefore the globe is wrong. No, you didn't. You just said that the straw man is wrong.
Okay, hold on. Now, this is okay.
Let me give you an example. That is
right.
That is the so-called black swan is a straw man of the globe because they intentionally leave out the refraction information. They take it's QE, and he went to Andrew Young, PhD at San Diego State University, found his page on the distance to the horizon, read that up to where it before it talks about refraction, and said, there it is, that's the distance to the horizon, it's the height in feet times 1.225, something like that. I'm not quoting it exactly. But the very next part of that page says refraction considered simply. And QE did not read that. He did not include refraction in his analysis. It is a straw man. So he didn't disprove the globe. He disproved a straw man of the globe, which doesn't do any good. So don't do that. So here's my recommendation to you. Analyze the actual globe, not a straw man of it, or find actual evidence supporting flat earth, which you've already admitted doesn't exist. So it's a tough one.
I think what I admitted was that it would not be accepted. There's no way you're going to go over. You're not going to go over the tests and the things like that for people. It's too. It gives too much of a new reality. It's too much like, oh my goodness, you're telling me God exists? Oh no, that's scary as hell for a lot of people.
Keith, 2 billion Christians agree the Earth is a globe.
Are you saying these 2 billion Christians are just the most extreme mathematicians you ever met, and they know how to study
what
this
I'm
stuff?
saying, what I'm saying
What
is,
does that matter?
What I'm saying is that 2 billion Christians don't have a problem with the Earth being a globe.
I'm saying
And
too many
they
Christians have not
still-
gone through the process of learning about it.
But they still believe in God. That's the thing. It's not like, oh, the Earth is flat, therefore I will believe in God. No. 2 billion Christians already believe in God, even though they don't think the Earth is flat. You're not going to convince them any more than they're already convinced.
Well, hey, as long as they believe in God, they good to me. Whatever. But I'm still going to say they haven't gone through that process of the real mathematics and the real science and the real digging through to know for sure either way. That's what and every person needs to go through that journey for themselves.
The thing is, they don't.
I didn't say they did.
Standing
I
on,
said you should.
standing. You said need. You're standing on the shoulders of giants, right?
Okay, yeah.
So I don't go every time I drive my car and redo all the engineering to build the car. I trust the people that engineer the car to make it work. When I sit down on this chair that I'm sitting on, I don't go and verify that all of the joints are correctly made and that they're going to stay together. And I don't go cut down a tree every time I sit down. I trust that the people that did that did it right. And
what you
it
trust is
shows
quality
itself
control.
to be, and it shows itself every time I sit in this chair to be correct. Now, sometimes chairs break, of course. So,
Right.
all right, let me read this because he gets upset by this, and rightly so. Kyle Silverfur says, Keith, scripture does not teach flat earth. You flatties need to stop misrepresenting the Bible. Stick to the science you constantly misunderstand.
Now he knows darn well we always give the same scripture to look at. If you look at it and you say it's not the case, no problem. I'm not going to argue with you.
It is a personal interpretation of it.
I'm not going to argue with that.
Absolutely.
That doesn't mean whoa. That doesn't mean you're right. That doesn't mean you're true. What I'm telling you is that I would not argue with you about that. That's all I'm saying.
Yeah, exactly. It means nothing. What it works out to be is a claim. It's a claim.
Okay. And who argues that though? At the end of this, listen to me.
Flat earthers do all the time.
This is what I'm talking about. It's fine. It's that claim, but you gotta let it go. That's just what some people think. There's their reasons you may not agree with. It's fine.
The thing
but
is,
they go to it for their reasons.
So
and if it's not true, it's not true. Let me put it this way: since these people aren't even in science and doing these things, what's the problem?
Well, there's some problems. It damages people's logical reasoning ability. It creates in them the ability to accept things that are not true. Right? And that's a problem because it affects other parts of their lives and it affects society as a whole.
Dude, that's life. That's life.
But absolutely, but that's the reason why it's a good thing to stand against it. To educate people and to challenge them when they come up with these things, because the logical reasoning process that leads you to certain false things thinking that they're true will cause them to do other things similarly, and that might have a much worse impact on them. So
they're still not the people doing the rocket, so it don't matter.
So all right, Humphrey Pushcart says for $6.66, just wondering, does Keith exhibit the same contrary personalities issues when discussing illness with a physician?
Oh, now here we go, right back to what I said to people: is nobody lying to you. They're just being quiet because what is the point of going through all of this?
Let's go. Let's get real concrete on this. You go to the doctor. He says, Keith, you've got syphilis.
So, and it's a silly thing to bring up. I'm not going to go to the doctor and say, "Oh, I don't agree with you." That's not going to.
Okay, so you're not going to. Okay, so be right. You're not going to say to him, Did you build that test yourself? Did you go to somebody that has that disease and personally extract it and do the, Koch's postulate to make sure that it? No, you say, oh, you have a test that you got from the cupboard,
Right.
and you put the swab in the whatever test said this. So if you're not going to be critical about that, then you need to be, I think a little more honest to say, okay, hold on a second. Snell's law seems to work. Refraction doesn't do things that way.
You're right, Tony.
So
this
then
is why
what?
we come to this area. No, you're right. You're right.
So
you're right. So everybody out there, just know nobody like me is lying to you. Nobody like me is just they're trying to hide the information. Look at what happens. They're going to stick with the things as they know. That's where it's at. So that's what I'm saying. Don't get too caught up in the argument. Like, I talk to Tune, but I don't argue with anybody. I tell you what it is. You accept, you deny, I move on.
All right. Connell Silverfur comes back again. He says, you use Hebrew poetry to support your fallacious assertions regarding the shape of the earth. Poetry is not science. Now, Keith doesn't do that much, right? I haven't seen you on Facebook or elsewhere saying, look at the Bible and that's what it says, and my interpretation of the Bible is the right way and everybody else's is wrong. I've not seen you doing that, right? You say you say you're Gnostic. You're not. Right. You're not typically a lot of the flat earthers that go to the Bible are hyper literal fundamentalists.
Right.
That's not.
Well, you. I do think it's. Obviously not when it's talking about God's heart, but I do think it's. You should take it as literal. I do not believe you should take Scripture as allegory. I'll say that. You should not do that. I think it's actual history, and it's actually telling you, it's giving you our cycles, our rhythms, and the energy that's here.
There is historical stuff, but you can't take things literally. There are many things you cannot take literally.
Like God's heart. I already brought that up.
No, like physical things.
Like what?
There's in Leviticus, I believe. Could be Exodus. It describes the dimensions of a giant bowl. And that giant bowl, it says the diameter is 10 cubits and the radius all the way around is 30 cubits. Right? That is a rough approximation.
Okay.
But the number should have been 31 around the perimeter. So it's a pretty large margin of error, and they could have just said 31 instead of 30 and been more accurate.
You know what, Tom? I got some. I want to get into that. I'm going to the restroom right quick, though. Okay, I got to use the restroom.
You got
be right back.
Okay.
All right.
All right.
Be right back. Hold on.
All right. While he's gone, Fat Man says, "Hey, MC Tune, when you gonna write a book?" Number one, I'm busy. I got a lot of things to do. I got 13 Mark Steele videos planned. Short ones. Oh, poor guy. But yeah, that's a good book. Just go buy that one. I don't know. If you've not seen it, I'll take this. The Mark Steele video that I came out with yesterday, I had so much fun. He actually claims that the Ark of the Covenant was a 5G. He says 5G. The Ark of the Covenant was a 5G directed energy weapon. Mark Steele really said that.
I'm back.
Not just once. Just a second, Keith. He didn't say that once. I have him saying that 4 times in that video. So if you have not seen that video I did on Mark Steele yesterday, it's just the stupidest thing ever said, is what I call it, something like that. Go watch it. And then I would love if that video took off a whole bunch. So if you can send it somewhere, if you can post it on social media somewhere, if one of the mods could grab it, throw it in, I would just love to see that video take off. It is not my number one video so far, as far as time frames. So, all right, Keith.
Boom. You there? All right. Now, you just gave me 10 over 30, right? 30 over 10, right? For your numbers that you were giving.
Yeah.
All right. That sounds like a good old 3 to me. You guys always say that 3 is not pi, correct?
3 is
Can
pi.
I wow you?
3 is pi to one digit, one significant digit.
Okay, okay. And you know, you say flat earth people don't do math. Okay, so let's try this out. Now, I'm sure in talking to you, you won't be like other people. You understand that if I don't use degrees, I am automatically talking radians, correct?
You're going to use radians? Right.
Okay, so therefore, I want us to take pi over 6. What does that equal? 30 degrees. What does that equal, Tom?
Pi over 6?
Right. 30 degrees.
In radians to degrees.
No, it's 30 degrees in radians. I mean, pi over 6 is 30 degrees.
Okay.
Okay. Now, so let's just take sine. Sine 30 degrees. Sine 30 degrees is sine pi over 6, which is equal to 1 over 2. So if we multiply both sides by 6, guess what pi equals?
3?
There
is
you
that
go.
What you're doing?
There you go.
No.
Deny it through the math. That's the math. Deny it through the math. Deny it through the math, though.
Because oh, Keith.
You can't. What you got, Tom?
You can't do that 6 that's inside the sine function. You can't.
No. Radians are real numbers.
Hold on.
Just like the 1 over 2. That's what you see. Wow.
But
I'm the one that don't do the math. Okay.
That's a great trick. I love that. All right, let's.
That's what it is.
I'm gonna write it down as you do it.
Write it down. This is exactly why I did my deep dive in trig. This is why I wasn't just doing some triangles to learn. I was like, hold on, let me get into this.
So pi over 6.
Pi over 6 equals 1 over 2. Multiply both sides by 6.
Approximately.
No, actually, and that's the thing about it. Think about it. No.
Only to 1 degree.
Well, not think about
or
it.
One significant digit.
It's the 45 degree and the 60 degree that are a little bit more approximate because they have the radicals that you have to divide. But with 1 over 2, it's a straight clean number. And if you do that 6 times, pi at 180 degrees equals 3.
Hold on. I got pi over 6. We'll walk through it again. Pi over 6, and you want to do
1 over 2.
Sine.
You can, but it like sine pi over 6 just means 30 degrees, basically. So it's just letting you know at that 30 degree mark, you're going to use that number for it.
I got sine of pi over 6.
No. It's sine 30 degrees. And so that equals pi over 6.
Are you not aware that you can do sine in radians?
What do you think? I thought, my goodness. I don't want to go through this FDFE crap again. Now, come on now. It's either degrees or radians now. Okay, that's all there are. So, I'm saying that sine 30 degrees is equal to pi over 6. So that's your radian number, that pi over 6.
No.
And that real number in radians is equal to 1 over 2.
Wait, why are you saying that sine of 30 degrees is pi over 6?
All right, don't worry about it. Hey, I'll get y'all trick books. But I don't know the math. All right.
What?
I don't know, man. I can't help you with that one. I don't know, man. Y'all got to know y'all math when y'all talking to me. Like, come on, man.
I'm trying to follow. That's all the farther I got.
I know. So bottom line, where's the equal 1 over 2? That top pi over 6 should have equal 1 over 2.
But it doesn't. I can do this. It
does. Hey, y'all getting y'all trick books and y'all tell me from there. This is exactly why everybody needs to do all this information for themselves.
Approximately equal. Hold on. Approximately equal.
All right, so whatever. I mean,
that's all you get. It's
really okay.
It's
look,
accurate to only one significant digit. That's not very accurate.
You're going to say that, but the real approximations are with the 45 degree and the 60 degree angles. Those are the approximations because you have an endless number that has to be divided by 2. That is not an endless number.
Did you get this off of a website?
Okay. Now who's being insulting towards intelligence?
Somebody in the chat is saying that you got it off a website and that you didn't come up with it on your own.
Are you talking to the Trig Master? Is that who you're talking to? Come on.
I am certainly not talking to the Trig Master.
Exactly. But what I meant was from your chat. Oh, you definitely talking to one now.
All right.
Process.
All right. So I'm still waiting here.
Okay, fine. Leave it at that. But still, multiply both sides by 6 and you're going to get 3. That's fine. So you have 5 to approximate for 3.
I don't have 2 sides to multiply by.
You do. That pi over 6 is a real number. That's the point of a radian. That is a real number. That's not just degrees where you
Yeah.
don't know how to translate it into what
Okay.
is equal.
Here, hold on. Is this what you want? Hold on. Is that what you want?
You can do that. And what is that
Right.
number? And what is that? Fine. What is 0.5? That's fine. We can do that.
Yeah.
Nice clean number. What is
It's
0.5?
correct. It's correct.
Does that not equal 1/2?
Yeah.
Okay.
Okay, now what?
Multiply it. Now, fine. You can even use 0.5. Multiply 0.5 by 6. What number do you get?
3.
You're going to get 3.
Okay.
Thank you. So you guys are wrong that it does not equal 3.
No, what do you?
More than likely,
Wait.
let me finish
What
this.
am I supposed to do? There's nothing wrong with this equation yet.
What are you talking about?
Do you want me to divide both sides or multiply both sides by 6?
Well, that bottom one is wrong because you got the sign there. Once you have that sign, you don't really need the sign there. Like for that bottom one that you have,
you want this top one, but that's not correct. It's only approximate.
Let's try listening right now. For that bottom one that you have, that sine pi over 6, that would be sine 30 degrees.
Okay.
You would translate that into
I'll write it
pi
down.
over 6 because that's a real number.
Okay. Now what? Is that what you mean?
So if you multiply 0.5, you get 3. You trying to play games? You got it. Go on. Let's move on.
I'm not. I'm trying to follow along with you and do what you want me to do.
Our approximate, let me go another way, whatever. Our approximation for 90 degrees is 1.57 because that gives you the 3.14 once you get the pi. So we're going to say 90 degrees is at approximately 1.57. However,
What?
you add those dang,
in radians? In
hold on,
radians?
man. I know y'all slow, but hold on. So if you add those three 30 degrees together, you're going to get 1.5. That's going to be close to what you guys have in the approximation. But the 1/2 is sweet because it's a clean number. As a matter of fact, if you try to do the 45-degree number or the 60-degree number into the 180 degrees, it would be lower than 3.
Hold on. I'm trying to follow along because this is.
I don't know if
this, you what? Pi over 2 is 90 degrees. Yeah. Now what?
Yeah. What do you mean what?
Now what?
Nothing to him. Don't worry about that. Nothing. Don't worry about that. Get in your trig books.
Here's what
you're acting like you can't multiply that real number by that number that you see over that rating. You can.
I can multiply.
Tell you what it is.
Tell me specifically what you want.
Okay, look, very specifically, man. Come on now. The top one that you have, just multiply both sides by 6, dude. What do you get?
I get pi
equals 3.
No, it's approximately equal to 3. That's all you get. You don't, just because you multiply by 6 doesn't mean this approximate turns into a not approximate. It's still approximate.
Okay, fine, go with it. So what? But that shows you that in that approximation it is 3. Fine. But you guys keep saying it's not 3.
That's
I can show you by the numbers of trigonometry
that
it
information.
does.
It's approximate to one significant digits. Pi is 3.
So why say the pi? So why say pi can't be? So you don't see pi as something that could kind of. That's right. You guys don't see pi as kind of fudgeable. Let me put it that way.
It's a ratio. It's a ratio that you can't cheat. You just go measure it. You measure the circumference. You measure the diameter.
You're gonna say it's supposed to be exactly to some sort of little pinpoint number in the 20th digit past the point, whatever. And y'all got it on that.
The more precision that you use to measure it, the better, of course. And it's never just 3 if it's high precision. It's 3.1415. I don't know what you're getting at, but I think let me do this again because I think I know where you were going with this. And the Logical Hillbilly says, seems like this is the mathematical equivalent of the shell game. Don't think he's trying to. I think he doesn't quite.
He doesn't understand it?
I think that you don't quite. All right, so I'm going to do this again.
Yeah, it's hard talking y'all with the math, man. I thought y'all were better at this.
Okay. Right here. Sine of pi over 6 is equal to 1/2.
Sine of 30 degrees. Nope. Sine 30 degrees is equal to pi over 6. You gotta start there first.
But that's not right.
Okay.
Because
Why don't you Google it right quick, Tony? I mean, geez.
sine of 30 is not pi over 6. Sine of 30 is 1/2 or 0.5.
It equals 1/2, and it also equals pi over 6. Yes, I know. That's what I'm trying to give you the way to do it.
So
You're going to
now
do sine 30 degrees equals pi over 6. Pi over 6 is equal to 1/2. Since pi over 6 is equal to 1/2, that gives you the ratio of what pi is.
But sine of 30 degrees is not equal to pi over 6.
Okay.
In fact, I'll write it down.
That's its radian. I don't know what the heck you're talking about. Just like pi over 12 is the radian number for 15 degrees.
I'll write it down here. Sine of 30 is not equal to pi over 6.
Okay. Again, people, this is what I mean. Why do this argument? A math book is right there. It'll tell you. If Cat's going to argue over this, why do you guys think they're going to not argue over something even deeper? Come on now. Okay.
Because you're wrong. Because none of this is right.
Okay. Hey, okay. If Professor Bell is in the chat, I dare him to co-sign you. How about that? I'm calling out. Y'all know I'm calling out.
You dare him to co-sign me?
I dare him to co-sign you. I dare the professor to co-sign you. He cannot. No mathematician could.
To co-sign me?
Your false attempt at math. Yes.
Is Professor Bell, are you still here? Oh my gosh. All right, I didn't get to, I think maybe I'm wrong. I had a thought about what Google pi over 6.
You know what I also want to get into too?
Hold on.
I don't really know exactly. This is why I kept telling you guys. I said, well, pi is a ratio. I don't know exactly how they got that number, because it's also a number that keeps stringing along. I'm like, well, hold up. How did you get to this? I mean, you're doing that, but I know you didn't look at it. You don't know how they got that number. That's why you're doing it. You guys
I know how they got the number. They measured the circumference of a circle, and they measured the diameter of a circle, and they divided them. And they're like, hey,
found out it was an endless number.
It doesn't matter how big. It doesn't matter how big of a circle we have.
Understood.
The ratio's the same. So how do they know that the number, that it's an irrational number, is what you're asking? How do they know it's an irrational number? Yes. I
need to go over that. I would have to go over like the stuff that got them into that.
It has been mathematically proven.
I'm not saying it's not. I just gotta go over it. That's what I'm saying. I gotta go see what they did and how they got off.
Why do you think that pi over 6 is equal to 1/2?
I'm done with that one, man.
That's what people.
All y'all gotta do is get into a trig book, folks. That's all you gotta do.
But no trig book says that.
Okay. No, for yourselves. This is exactly why we say trust no one. Okay. For those of us that believe in secret knowledge, say trust no one.
But then you said trust a trig book, which is written by a person. Where is it?
Because I'll go with that's peer review mathematics. Come on now, Tim.
Just a second.
You guys really get locked up with this man.
All right. All right. What page of this book should I go to that says pi over 6 equals?
I think isn't that more calculus or something, man? I don't think that's the trig book, man.
You don't think there's trig in here?
I don't know. I'm asking you. You're the one who took that class. I haven't looked over that yet. I do want to look over that book too. I do want to see what you went over too.
Well, there it is. It's
that's for engineering, right?
Advanced Engineering Mathematics by Erwin Krasik.
What year were you of school when you took that one? Is that 2 or 3rd year?
That
or 4th.
I don't know if it's my 2nd or 3rd year of university.
Is that right? 2nd already, and then going after? So you already finished your other calculus classes then before that?
Yeah. Calc is year 1. I did calc in high school.
Right.
So Vadim is asking, why would MC2 have a book like that? Wasn't he a software guy? I had a double major, computer science and electrical engineering. That's why. But I'm like, I enjoyed much of the electrical engineering, but I really enjoyed the software stuff. I would find that I would do my software homework first, go do some engineering homework, and then be like, oh, that's kind of, and then I'd go back and just do extra stuff in software.
Yeah.
And I'm like, what am I know what my career is going to be. So, I just really enjoyed the software engineering. So, finished calc. Yes, I did not finish calc in high school. I took calc in high school. So basically an entire year of high school calc is like, one semester, 1/4 of calc in college.
Right.
So
in college,
so all right, so here is Humphrey Pushcart says, Keith, when does your fondness for conspiracies become paranoia?
What conspiracy did I bring up?
in general, the secret knowledge. What is your doctor, a scientist, not telling you?
Did I say anything like that?
I don't know. Doctor is a scientist.
Folks have a lot of projection from. Sure, but they should probably listen to what the person's actually saying and not generalize. If I don't bring up conspiracies, there should be no reason that it's brought up.
Well, you did though. You talked about secret knowledge.
That's not a conspiracy.
It's secret knowledge. How is that not?
Right. That's not a conspiracy. The conspiracy would be NASA stuff and all that. Come on now, you know the deal. That's the conspiracy side of stuff. I'm not saying anything about that.
Talking with flat earthers, every one of you is different. Every single one of you has a different idea for how the flat earth works. None of them do work, but everybody has a completely different. I'll give you that. You're all unique snowflakes in that. So some are like, I just look at the Bible, and some try to actually science it.
Right. Now I will say this. For those who have that faith and believe it's out the Bible, hey, you're doing a good thing, man. You're doing a good thing. I would say beyond that though, go ahead and go for the science. You will find it's true. I'll say that. But you gotta really be really good at the science to really
to find what will you find is true if you really go for the science?
I think if you really work with the science, especially with trigonometry, you will find that it's flat. I do think that you will be able to get those dimensions. You know what? You guys have been clamoring for a map.
Bring it.
You guys have been clamoring for a map. I'm going to give you a map, damn it. I'm going to do it, okay? I'm tired of y'all with this map stuff. I'm going to go ahead and get a map. When I get that channel, I'm going to plot the cities. I'm going to put that map out. I'm going to say, here y'all go. Now what?
I look forward to you doing that, Tiger Dan.
Because he was a mathematician, right?
Tiger Dan? Oh, no, he just did what you said you're going to do, so.
But he was a mathematician, right?
I don't think so.
If not, then why does whatever he came and concluded with matter?
I love what Tiger Dan concluded. I thought that's fantastic. Do you know who Tiger Dan is?
Maybe not exactly.
Okay.
I thought he was the one who tried to make the map. He tried to do a flat Earth map, but it didn't work or something like that.
Yes.
You're going to need to be serious in your math if you're going to do that. So if he's not, then there's no way you can make it work, dude, until you start getting into that math. That's the only way it's going to work.
All right. I look forward to that. You don't even need a channel to do that. You can just start on it now.
Oh heck no! I want that. No.
All right. That way. Do your first video. I'll send people to it. Let's see.
I don't know. I might have comments off. I won't lie.
Chronic Avenger says he should watch the Veritasium about finding pi.
Okay.
There you go.
All right. Yeah. Okay.
Veritasium, he does a great job explaining things in a very reachable way. I think.
I don't know about all that. But...
So yeah, Safety K knows who Tiger Dan was. Tiger Dan, he's like, I'm going to get the map. And so he took the distances between the cities, which are knowable because planes fly them, and the speed at which a plane can go and the amount of time they're in an air can confirm how the distance is. Right. And if somebody was really like, well, I don't believe that's true, then they can get on it with a GPS and measure the distance, measure their speed, all those things, and find out, oh yeah, it's right or it's wrong. You'll find that it's right. So he took those distances, put them on a flat map, and put the cities on there and had the continents move around with them. And he could put 3 of them on. But as soon as he got 4, he couldn't get the things to work. And as he got more and more cities on there, he's like, I can't find any possible configuration where these distances work.
Now, is the issue that they didn't line up with latitude and longitude numbers?
He
or
wasn't.
Else?
No, he wasn't. He just had a white, empty. It looked like it was just a paint, like Microsoft Paint, and he was moving these things around. And he's like, all right, well, here's a ruler. This line is as long as this flight. Okay, I'll put it on. Right. I'll put it on New York City, and I'll put it on London. Right. Okay. And then, all right. And then New York City, there's a direct flight from New York to Sao Paulo, Brazil. Okay, I'll put that on there. And then there's a direct flight from Sao Paulo to London. Okay, I'll put that. There's a triangle. That works. Right. Any 3 points can be put on a triangle. Okay, so now let's take the flight from New York to LA and from LA to Sao Paulo. Okay, that sort of works. But then let's get London to LA. I don't know if that exists or not. I'm just making things up. And we'll put that on there. Oh wait, I can't make them connect. It's way wrong.
Well, what's telling them that? What's wrong? That's what I'm trying to figure out.
What
can he connect?
He measured the length. He said, okay, here's my scale. This many pixels is this many miles. So the distance from LA to New York is this many pixels long. And the distance from New York to London is this many pixels long. And he put those on there, and then he tried to make the cities match. Because if that's the case, if the Earth were flat, then that's all you'd need to do is just plop, plop, plop. And they would all just line up, and he could not make it happen. And as he added more and more cities, more and more things could not be forced in. And he's like, and he's deleted his channel since, and I did not download the videos, but at the end, probably somebody has them. He's like, Australia is here and Australia is here. He had Australia in 2 spots because he's like, that's all I can do. I can't make it fit. And even then it's still not fitting.
I wish I could look over that, but let me ask you this. Go ahead.
Anyway, the point is, he's like, he started out with the video saying, I'm going to do this. And he was super excited and confident. And then 1, 2, 3, 4 videos in, by the time he got to the end, he's like, I can't do it. I give up.
Right. Now let me ask you this. When it comes to the planes in the sky, do we know how fast those winds are at that height?
Yeah, they're not that fast. But of course, Jaron tried to claim that the flight between Santiago and Sydney, Australia, went as fast as it did, and that the Earth is flat, and he uses the AE map. He's like, it's because of the winds. The problem is that for flat Earth, if you draw a straight line using the AE map between Sydney and Santiago, it's about 2.5 times the distance as the plane actually flies, and it goes over a dramatically different area. If you take that flight and put it on the AE map and actually have it go around that big curve that shows up on the AE map, it's not just 2.5 times farther. It's much, much more than 2.5 times farther. So in order for the winds to answer the question, the winds would have to be traveling 1,000 or 2,000 miles an hour in one particular direction. And then when you fly the opposite direction, the winds would have to have changed direction. Doesn't really work. So.
Now the winds around Antarctica are stronger though than the winds, say, around the equator, though, right?
It's not going to be 1,500 miles an hour.
Okay, and right quickly,
it just
and even though, right, and even though you said the number was small, what is like the wind speed up there around 35,000? What is it?
I don't know off the top of my head.
Okay, all right.
But Fat Man says, was his math example trying to prove God was right? Oh, that's a good question.
Whose? Mine or somebody else's?
Yours. When you tried to say that pi equals 3, was that an attempt to suggest that that measurement was correct from the Bible?
From scripture, yes. Yes.
Okay.
Yes.
There you go, fat man. Small Time Arts, his friendly reminder, 33 has a tiny W3INER.
What the heck is that?
W3INER? I don't know. Maybe you could write it on your forehead and ask people what it means. What it says.
Oh, got you. Okay. Why they got to jump on them like that? Come on now. See all that.
I don't know. Do you want to be a member of the Pen 15 Club?
Pen 15. What is that?
Well, what you do is you take a marker, right, a permanent marker, and you write Pen 15 on your hand. Yeah. Just
for what? Just to do
and then you're a member of the Pen 15 Club.
Oh, okay.
There you go. A Cretan ball for $5 says before Newton, pi was calculated by bisecting angles. Newton realized that Pascal's triangle and negative numbers in binomial theorem would solve for it.
Okay, so I'll check that out.
Yeah, there's a mathematical way to calculate arbitrary digits of pi. And NA says that the speed of those winds are 80 to 120 miles an hour.
But that would be more for like northern, and I would think not so much Antarctica and those winds. But okay. But all right.
My guess is it probably doesn't stray very far from that. It certainly isn't reaching the 1,500 miles an hour that it would have to. So.
Well, maybe not that, but maybe 500 to 700, maybe.
Still doesn't solve the problem.
All right.
That's a long flight. And the wind has to go one direction while they're flying one way, and the opposite direction as they're flying back.
Well, yeah. You got to look up the numbers to see what's what.
Yeah. Peter Miss Prime says if F equals ma, then Earth cannot be flat. The end.
The end. Moving on, true. Everybody. You heard it. There it is.
True that.
That's why there's no arguing that.
QED, in decades of Bible study, I've never read pi equals 3. It's not strictly saying pi equals 3. It's the ratio of the measurements of the bowl that was in the temple. So now one other thing about taking things literally, Song of Solomon 4 says her eyes are doves.
And that's why I went right back to, it speaks about God's heart. That's not literal too. And I think when it comes to Song of Solomon, you should understand that's more poetic, right?
That is exactly my point.
But that particular one,
there is poetry. There is poetry. There is allegory. there is non-specific things. There are things that are not meant to be taken in literal ways, and there are things that have strong cultural meanings that you don't understand if you just read it and don't have the cultural background there. There you go. Small Time Art, I do know that it means wiener. Small Time Art, I was never actually a member of the Pen 15 Club either. Do you know? Did you figure out the Pen 15 Club yet there, Keith?
A little bit. I think so. Yeah. Based off of the W3. Yeah. I see what you did there.
Yeah.
I think.
I don't know.
But it's a certain anatomy in our midsection, right?
Yeah.
Am I mistaken?
Okay. So you start by writing pen, right? And then you just add
right.
You just add 15 to it.
Right.
Like that. So there you go.
Oh,
That's
you go.
The Pen 15 Club.
Right.
There you go.
All males, basically, right?
I'm sure somebody's gonna clip that. All right. Why does a sextant work if it cannot work on a flat Earth?
That's what I'm told. I gotta go through it, don't I? They tell me that. That's what they tell me.
I would love to see you do some.
That's what they tell me.
Keith, pick one thing. Pick one thing. Work through the math on it. If you need, I will send you a couple pictures from this book, and to help you along. There's a lot of matrices in here which you may not need, but if you do need matrices or triple integrals, there's plenty of triple integrals here.
All
There you
right,
go.
I'll see.
There you go. Fat Man is asking, Keith, did a snake literally talk to Eve?
I do think that. I do think it did. Yeah. I do take it literal to mean that at that time we could talk to the animals, and because of our sin, we fall in and out. We can't do that, and that
Well,
obviously strains our relationship with them. And
yeah,
stuff like that.
Harry Potter can.
Well, there you go. They're trying to tell you. We always tell people. They tell you stuff in the movies. They are secretly telling you things. It's just whether you pick up on it or not, and whether you can.
Because it's a conspiracy.
The problem with a lot of people is they go to the conspiracy. I say it's all evil. It is not. You can take it both ways. So you guys have to kind of get out of that everything is satanic just because it's not something you're used to. It's just secret knowledge and stuff that's kind of put to the side because of all this. I mean, you guys should open your eyes to this. You see what's going on. So that's why it's to the side. If you want to go to it, go to it.
So, Scythe DK is wondering, have you ever opened a book on spherical trigonometry?
I have the trigonometry we study in school right now.
So is that a no?
I have no idea. The one we study in school. Is that, you tell me?
Well, my sister was taking a class in college recently, and it had a prerequisite, or not a prerequisite, for her graduation. She needed to take a math class, so she was taking her remedial math class, and she needed a tutor. That was me. The topic was spherical trigonometry. Funny enough.
But I'm saying, what was the name of the, okay. Her class was not trigonometry though, whatever it was.
It was a math class.
Right.
So in that math class, it covered spherical trigonometry.
Now, when you say spherical trigonometry, are we talking basically like the degrees that go around the wheel? That go around the circle?
No.
That's not that. Okay.
No. Here's the thing. In Cartesian coordinate systems, you have X, Y, Z, right? And everything is linear, and that you can just use the Pythagorean theorem to get the distance between things, right?
Right.
Well, that's a Cartesian X, Y, Z. It's rectangular sort of. But if you were to have a coordinate system that was on the surface of a sphere, a straight line on the surface of that sphere, when viewed outside that sphere, would be a curve. But on that sphere, it's a straight line.
Right. It would be like looking at it from the side, it would be like a arc length, but then since you're looking dead at it, to
yeah.
you, it's just
and
right,
in fact,
right.
On the surface of a sphere, if you a straight line in one direction joins back up with itself. But on a flat surface, in Cartesian coordinate system, a straight line never does. Yeah. And on a sphere, lines cannot truly be parallel if it's a straight line, because two straight lines will cross and then they'll cross opposite each other and come back around again. That's how straight lines work. It's easier to take the analogy then of a polar coordinate system, for example. Polar coordinate system, you don't have XY, you have the radius and the angle. Right. So you know how far from the center it is, that's the radius, and then the angle of the center. So to draw a circle, the formula for a circle in polar coordinates is r equals 1 for a radius 1 circle. The formula for a circle on in Cartesian coordinate system is x squared equals y squared. It's not nearly as simple. So and you can do other coordinate systems as well on different surfaces. So you could have something on the surface of a cone, for example. So on the surface of a cone, a straight line going towards the origin would be straight in either direction. But if it was slightly to an angle, it would form a spiral that was increasing or decreasing in diameter.
Right.
A helix, if it would be better. There you go. Scythe DK, Says, I don't think he understands it. Spherical geometry is kind of complicated, but he'd need to understand it to debunk the globe if he wants to. Yeah. But what he wants to do, and I would prefer this because it's so much more interesting, would be for him to try to find something that works for flat Earth. Put together a hypothesis that when you test the prediction, like for the sun, the elevation of the sun, that when you test the prediction, it says the flat Earth says the sun should be this high. That would be amazing. It won't, but
nobody is trying to. I'm not trying to disprove globe. I already know how this works, so I'm not even trying to disprove it. I just kind of point people in the direction if they themselves want to go down that journey. That's all that.
Yeah. So Fatman says, Toon, you would have time to write a book if you stopped debating idiots on YouTube. So much more fun. So, all right. Well,
that's the mathematician.
Yeah. All right. Well, that is. It's been 2.5 hours.
It's been a good little time.
What's that?
Yeah. I said, yeah, it's been a good little time.
All right.
Going over a few little subjects and everything.
Tomorrow at 8 p.m. Central is Tony Nahum from Australia.
Okay. All right.
And
Tony go over numbers too now. Tony goes over the numbers.
He will probably have a little bit more numbers there. So
yeah.
I don't know. We'll see. We're gonna have a structured debate. It should be pretty interesting. So be sure to show up for that, people. Southern Hemisphere Globehead says MC Tooney won't be able to find math for flat Earth because the Earth is a globe. I agree. That's why I think it should be his goal, because he will, if he's true to himself and he's honest, he will try and try and try, and then eventually decide, you know what, none of this works. Screw it. You're right. Everything for a globe works and nothing for a flat Earth does. Anyway.
Well, that is the answer to tell the public. I will say that. Say that.
All right. Well, anything you would like to say, Mighty Python Black Knight?
I think just like I said, folks, if you are FE, don't go with the herd. I mean, there's a lot of things out there when it comes to FE. Anybody in FE should be telling you, you got to research for yourself. So go do that. You guys got to get into the math. You guys got to stop denying 10 to the negative 17 as a positive number. It's what it is, dude. It's just what it is. So, I mean, just it's okay to go with the science. You're going to find that the conclusions they come up with can be altered. So for you guys out there, stop blaming people. Focus on God. Focus on intelligence. Focus on university knowledge, and just move in that direction.
All right. Let's see. Genju Hauman says is trying to work on his A+. He has a GoFundMe that he threw in there. I just pinned that there. So if you're interested, go ahead and let's see. Grab that. I'm going to grab that right now. There it is. All right. Thank you, everybody. Be sure to check in tomorrow. And I'm working on, of course, some more Mark Steele hilarity videos. We'll see y'all then.